Okay, so hello, welcome back. So in this video we will talk about the examples that we have here. Example number 11, continuing with the examples. And well, the question is basically the question is you want to prove that the tan inverse of let me erase all of this because I was working on this problem and okay. You want to show that basically the tan inverse of the square root of 1 plus x minus the square root of 1 minus x whole over the square root of 1 plus x plus the square root of 1 minus x is equal to pi by 4 minus 1/2 cos inverse of x for all x's between -1, -1/2 and 1. Okay. Now the solution, basically what you can do in order to simplify this, and basically you want to write this in terms of basically when you have the tan inverse of basically tan of x, that is equal to x if basically x belongs to the interval that is the restricted domain of the tan function. And the restricted domain of the tan function, as we argued before, is basically negative pi by 2 is negative pi by 2 to pi by 2, the open interval negative pi by 2 to pi by 2. So you want to write this in terms of somehow make it look like tan of some angle, and then that angle has to be basically it has to belong to this interval, and then you can write it as x, and then hopefully that x will be equal to this expression on the right, on the right hand side, and then you'll have proof that basically the LHS is equal to RHS, right? Now, in order to solve the problem, what you can do is that you can write the LHS of this expression, which is 1. The LHS of 1 is equal to the tan inverse of basically the square root of 1 plus x minus the square root of 1 minus x over the square root of 1 plus x plus the square root of 1 minus x. Right? So that is the LHS. Now, what you can do is that you can use the formulas that we had before. We said that basically 2 times, or basically cos of 2x is equal to 1 minus is equal to 1 minus is equal to 2 cos squared x minus 1 minus 2 sine squared x, and 2 times cos squared x minus 1, which means that basically you can write basically the cos of 2x is equal to 1 minus 2 times sine squared x, and so basically cos of 2x minus 1 is equal to negative 2 times sine squared x, and so 1 minus cos of 2x is equal to 2 times sine squared x, and then I can write this as 1 minus cos of x is equal to 2 times sine squared x by 2. And that is one formula that we can use here. the other formula that we need here is basically cos of 2x is equal to 2 cos squared x minus 1. And so basically I can write cos of 2x plus 1 is equal to 2 times cos squared x, and then I can write basically 1 plus cos of 2x is equal to 2 times cos squared x, and 1 plus cos of x is equal to 2 times cos squared x by 2, right? So that is again another formula that I can use here. So I write them over here so that we can use them. So 1 minus cos x is equal to 2 times sine squared x divided by 2, and 1 plus cos x is equal to 2 times cos squared x divided by 2. Now, having that in mind, you can see that 1 minus cos x and 1 plus cos x, so I can basically put x equal to, for example, cos of y, for example. I can put x is equal to cos of y, and therefore we will have basically the LHS will be equal to basically the tan inverse of the square root of, now 1 plus x would be basically cos of y, x would be the cos of y, so 1 plus x would be 1 plus cos y. 1 plus cos y is 2 cos squared x divided by 2. 2 cos squared x divided by 2. And then we have minus the square root of 1 minus cos x. 1 minus cos x would be 2 sine squared. Actually, this is supposed to be y divided by 2. And 1 minus cos y would be 2 sine squared y divided by 2. 2 sine squared y divided by 2. And then over here you have the square root of 1 plus cos x. The square root of 1 plus cos, actually 1 plus cos y. 1 plus cos y would be 2 cos squared y divided by 2. And plus the square root of 1 minus cos y would be 2 times sine squared y divided by 2, right? Now, over here, if basically I can write, for example, over here I have 2 times cos squared y divided by 2, the square root of that. I can write it as the square root of 2 times cos of y by 2. If I know that the cos of y by 2, is a positive value, greater than or equal to 0, right? Now, in order to decide that, and then by the same logic, I can write over here the square root of 2 times sine squared y divided by 2. I could write that as the square root of 2 times the sine of y divided by 2 if basically sine of y by 2 is greater than or equal to 0. Now, in order to decide these two things, we need to note that basically we said that x is equal to, we defined x as basically the cos of y, and then what we had as a condition was that x belongs to this interval, not this interval, but negative 1/2 to 1. Negative 1/2 to 1. X basically goes from negative 1/2 to 1. Negative 1/2 is less than or equal to x less than or equal to 1. which means that I can say that basically the cos of y, which means that I can say that negative 1/2 is less than or equal to the cos of y is less than or equal to 1, right? Now, what I want to check here, if not cos of y, but if cos of y by 2 is greater than or equal to 0. So now I need to somehow make some changes to this, to cos of y, so that it becomes cos of y divided by 2. And the way that I can do that is that I know that basically cos of, I know that basically 1 minus cos x is equal to 2 sine squared x divided by 2, and 1 plus cos x is equal to 2 cos squared x divided by 2. So 1 plus cos x is equal to 2 cos squared x divided by 2. 1 plus cos x is equal to 2 cos squared x divided by 2. Which means that cos of x is equal to 2 cos squared x divided by 2 minus 1, right? So now instead of cos of y, I can write basically, based on this formula, I can write cos of y as 2 times cos squared x divided by 2 minus 1, and that is less than or equal to 1 greater than or equal to negative 1 by 2. Now I need to get only cos of basically, actually this is supposed to be y. I need to get this as basically cos of let's do this the other way around, meaning that so this way we will run into problems, because suppose that I add 1 to all sides of this inequality, I will get negative 1/2 plus 1 is less than or equal to 2 cos squared y divided by 2 less than or equal to 2, for example. And when I do that, when I divide by 2, I'll get negative 1/2 plus 1 divided by 2 is less than or equal to cos squared of y by 2 less than or equal to 2 divided by 2 is equal to 1. And then again, I need to take the square root of all sides of this equation, which gives me the square root of negative 1/2 plus 1 over 2 is less than or equal to the square root of cos squared of y divided by 2, and that is less than or equal to the square root of 1 is equal to 1. Now again, I can write this as cos squared of, I can write this as the cos of y divided by 2 if cos of y divided by 2 is greater than or equal to 0, which again, that's what I wanted to find out, right? So we need to check this in a different way. So then what I'm going to do is that I'm going to erase all of these things. I found some way in order to check that, but now I'm not getting that particular solution anymore. And I think the only way that you can do that is using the same formula. There is no other formula that we have with which we could do that. So we said that the cos of 2x is equal to 2 cos squared x minus 1, right? Now, what I'm going to do is that I'm going to divide these angles by 2, meaning that I'm going to say cos of x is 2 times cos squared x divided by 2 minus 1. And so again, we will get to the same problem. Now let's see if we can do it in a different way. Now let's not use formulas, okay? I guess the formula is not helping me here. So let's not use formulas. Instead, what I can do, I want to know if basically the cos of y divided by 2 and the sine of y divided by 2, cos of y divided by 2 and the sine of y divided by 2, if these two are greater than or equal to 0. We can simply check them using the conditions that we have. So suppose that I put x equal to negative pi by 2, so I can simply check manually instead of using algebra. So we said that x belongs to this interval of negative pi by 2 to pi by 2, right? And here we said that x is equal to cos of y. And here we said that basically x is equal to cos of y. X is equal to cos of y. Which means that let me think through this problem. Okay, so you need to pay attention here, because of course there is one thing that you need to that of course you need to take into consideration, and nobody in these exercises wants you to take notice of these things, because it's just about, at this point, these exercises is just about thinking about, it's just about basically working with the formulas. They don't really need you to basically take into consideration all the constraints of the problem and that sort of thing. That sort of thinking comes into play when you're doing something with mathematics. For example, when you apply for engineering and then you want actually to do something with your mathematics, in which case, of course, you need to know what y refers to, you need to know what x refers to, you need to know the constraints on x and y, so that, for example, when you build a machine, the machine doesn't fly. For example, if the machine is supposed to do something, for example, fly 2 meters above the surface of the earth, then you have to make sure that the constraints on x and y have to be in place so that the machine doesn't vanish into the atmosphere or something like that. So these kinds of things are important when you are actually doing something practical with your mathematics, and then of course you can do that right here. So, but again, it's not really necessary for you to take these into consideration. Now, what I wrote over here was actually not entirely true. The constraint of this problem are that basically I know that basically x is between -1/2 and 1. So -1/2 is less than or equal to x less than or equal to 1. And I know that x is equal to basically cos of y. Moreover, basically I know that I want to write this in the form, for example, the tan inverse of the tan inverse of tan of y, and so of course, and that's that, and then from that, most probably I want to conclude that, for example, tan inverse of tan of y is equal to y, in which case the condition, the only way that I could do that is if basically if y is in the limited domain of the tan function. The limited domain of the tan function was basically when we defined the tan function, we limited the domain to negative pi by 2 to pi by 2, right? So that is if y belongs to basically negative pi by 2 to pi by 2, right? Which means that you can say that then another condition that you have is that y belongs to the interval negative pi by 2 to pi by 2, right? Now what I want to know is if basically is cos of y by 2 greater than or equal to 0, and if sine of y by 2 is greater than or equal to 0. That's what I want to find out, and that's the information that I have. Now, in order to investigate that, what you can do is that you know that your x goes from negative 1/2 to 1/2, including the two numbers. So if I draw a unit circle over here, and if suppose that this is your unit circle, and I do it clean and neat, and so now what happens is that basically x goes from x is equal to cos of y. X is equal to cos of y, and basically I know that cos of y, so what basically from these two equations I can conclude that cos of y is between negative 1/2 and basically 1, right? So what angle do I need? What angle do I need so that the cos of y between negative 1/2 and 1? So of course I know that first of all cos, I measured across the horizontal axis. That means that negative 1/2 would be some angle, would be some distance over here, and 1 would be this distance over here. That means that all of the y's in this unit circle, all of the y's starting from 0 all the way up to pi by 2, all the way up to negative pi by 2, the cos of all of those angles goes all the way from 0 to basically to 1, right? Because if you have a 90-degree angle, then of course the cos of 90 degree is equal to 0, and then as you decrease your angle, the cos of the angle is increasing, raising, basically reaching to 1, and then as you basically go towards negative pi by 2, the cos of the angle keeps decreasing and decreasing until you get here, in which case the cos of the angle becomes 0. So that means that all of these angles between 0 to pi by 2 and 0 to negative pi by 2, they all satisfy this equation. Of course, if I'm only moving between 0 to pi by 2, I'm not considering, or basically somewhat into the negative angles, of course. For example, even to negative pi by 2, for example, for the sake of this argument. And negative 1 by 2 is basically the cos of 60 degrees. You see over here, you know that the sine of 30 degrees is equal to 1 by 2. The cos of 60 degrees is equal to square root of 3 by 2. And also the sine of 60 degrees is equal to square root of 3 by 2, and the cos of 60 degrees is equal to 1 by 2. the exact inverse kind of thing going on here, right? That means that if cos is supposed to be 1/2, one possible angle would be 60 degrees, which is basically this angle over here. This is 60 degrees, and the cos of that angle is exactly negative 1/2. The cos of this angle 60 degrees is negative 1/2. And so, I'm sorry, this is positive 1/2. And so if I go to the second quadrant again, and do some angle over here, which is, now you can see that this angle over here is 30 degrees because this is 60 degrees, right? So if I have a 30-degree angle here, whatever this angle is, this angle is 120 degrees, of course, 90 plus 30, and this is also a 30-degree angle. So this is the cos of this angle would be exactly negative 1/2. And again, for negative 1/2, again, I need an angle that is 30 degrees less than 270 degrees. So which means that and then the cos of that angle would be again exactly negative 1/2, and this angle would be basically, this is 270 degrees, and this is 30 degrees less than that, which is 240 degrees, right? So that means that for the cos to be between negative 1/2 and 1, meaning that for the value of cos to be between these values, I can go from 0 to this angle. Now let's write these angles in radians. So this is pi by 6, this is 2 pi by 6, this is 3 pi by 6, this is 4 pi by 6. 4 pi by 6, which is equal to 2 pi by 3, right? So this is 4, 5, 6 pi by 6, 7, 8 pi by 6. This is 8 pi by 6, which is equal to 4 pi by 3. 4 pi by 3. And then this is 9 pi by 6, which is equal to 3 pi by, divide by 3, you'll get 3 divided by 3, 3 pi by 2, right? So for the cos to be between negative 1/2 and, well, this is necessary because I cannot use the formulas that fluently, so I have to resort to the unit circle. So for the value of the cos of y to be between negative 1/2 and 1, to be in this range, the angle y can go from 0 to 2 pi by 3, and it can go in the other direction to basically from 0 to, for example, to this angle, which you can say basically it is basically negative pi by 2 minus, for example, pi by 6, whatever that angle is, doesn't really matter what the angle is. But you can essentially move all the way up to here, and then move all the way up to here, and then the cos of the angle will be between negative 1/2 and 1, right? Now, moreover, what we had here was that we said that basically at the end of the day, y has to belong to this interval. Otherwise, in the end of the problem, I will not be able to make the conclusion that, for example, the tan inverse of, for example, tan of x is equal to x, because if I'm to write this, then of course x has to be, or y has to be between negative pi by 2 and pi by 2. That means that this is also one constraint. So what we learn here is that y can go from here, from 0 to this angle, and on the other direction all the way up to this angle. But because I need y to be between negative pi by 2 to pi by 2, then of course I have to forget about all of these angles here, all the way up to here or all the way up to here, which means that I can move from negative pi by 2 all the way to pi by 2. And that's the only thing that I can do based on the constraints of my problem. which means that basically we can conclude that y belongs to the interval negative pi by 2 to pi by 2. More than that I don't have, right? Now if y belongs to negative pi by 2 to pi by 2, then of course cos of, for example, cos of y by 2, suppose that, for example, y is some angle somewhere less than 90 degrees or even 90 degrees. Y by 2 would be, for example, 45 degrees. Then still the cos of 45 degrees is greater than or equal to 0. And if I go all the way up to negative pi by 2, and then still if I calculate the cos of y by 2 would be cos of, for example, 45 degrees, and well, the cos of 45 degrees is again some positive value, so I have no problem with this. Again, if y belongs to this interval, meaning from negative pi by 2 to pi by 2, if I go all the way up to pi by 2, then y divided by 2 would be some angle like, for example, 45 degrees. Sine of 45 degrees is some positive value. And if I do the same thing on the other side, meaning that if I take y as, for example, even negative pi by 2, which is not what I'm supposed to do, supposing that I do that, even in that case, y divided by 2 would be some angle slightly less than, for example, pi by 4, negative pi by 4, and again the sine of negative pi by 4 is going to be then we get a problem here. You see, we get a problem here, meaning that the angle y divided by 2 strictly has to be in the first quadrant, right? Otherwise it's not possible, meaning that if I take meaning that I will be limited to only the first quadrant, meaning that y can go meaning that I can say that y belongs to, for example, only 0 to pi by 2. Otherwise the sine of y divided by 2 will not be basically a positive value. So this is the problem with this problem. But in spite of all of that, as you can see, for example, in the solutions, they have actually written the square root of, for example, 2 times sine squared y divided by 2. They have written that as square root of 2 times sine of y divided by 2, which is based on the constraint of the problem is actually not right, right? So this is one way that you can, of course, you can use algebra as much as you want or as much as you can, meaning the algebraic formulae that we have in trigonometry related to trigonometry, but sometimes it's not possible and you have to resort to the unit circle, in which case what you will find is that, for example, is that basically the constraint on your problem, and then as you can see, then technically I would not be allowed to write the square root of 2 sine squared y by 2. I would not be allowed to write it as the square root of 2 sine of y divided by 2, but they have done that. And again, the purpose of all of these problems is for you to get familiar with the formulae, and then all of this business of considering the constraints on the the constraints, considering the constraints on the problem, comes in higher courses. For example, when you're doing some course in college or university, for example, when you're doing some engineering course, then of course then you'll have to analyze all of these and make the right decision. Otherwise, for example, based on you use your mathematics in physics and you use your physics, for example, in electronics, and you build something and it doesn't work. It's that simple, right? For example, you build an airplane. The airplane either will not fly, or it will fall, or it will do something funny, which is not really funny. So that's basically that. But in spite of all that, they have, for example, done this, which is technically not right. But considering the fact that here you're just supposed to work with the formulas, that's, well, fine. Okay, there is no problem with that. So now let's go back to the problem and see basically what we have here. So now to solve this problem, again, you can basically, now I'm going to forget about this whole business of domain and range and everything, and we will just simply work with the formulas. Okay, so now basically what we can do in this step, basically we can write this as the tan inverse of, for example, the tan inverse of, for example, square root of 2 times, for example, the cos of y divided by 2 minus the square root of 2 times the sine of y divided by 2 over the square root of 2 times the cos of y divided by 2 minus plus square root of 2 sine of y divided by 2. Now, what you can do now is that if you divide each term by square root of 2 cos y by 2, if you divide each term by square root of 2 cos of y divided by 2, you will have the tan inverse of square root of 2 cos of y divided by 2 divided by square root of 2 cos of y divided by 2 minus square root of 2 times the sine of y divided by 2 over square root of 2 the cos of y divided by 2 over square root of 2 cos of y divided by 2 over the square root of 2 cos of y divided by 2 plus the square root of 2 sine of y divided by 2 over the square root of 2 the cos of y divided by 2. And as a result, what we will have is that you can cancel these two out, cancel these two out, cancel these two out, cancel these two out, cancel these two out. And so you will have the tan inverse of basically 1 minus tan of y divided by 2 over 1 plus tan of basically y divided by 2, and then that you can write as the tan inverse of basically 1, you can write it as tan of pi by 4. You can write it as tan of pi by 4, tan of basically, I can write it as tan of pi by 4 minus tan of y divided by 2 over tan of pi divided by 4. I'm sorry, no, here you don't do that. So here you can write your 1 and write tan of pi divided by 4, which is equal to 1, which is, if you multiply it by tan of 1 divided by 2, you'll get the same thing, and then you can write tan of y divided by 2. And so what that means is that then basically you know that tan of x minus y is equal to tan x minus tan y over 1 plus tan x tan y, right? So then you can write this as, based on this formula, you can write this as basically the tan inverse of basically tan of pi divided by 4 minus tan of basically pi divided by 4 minus basically y divided by 2, and then you can write this as, and then you can write it as pi divided by 4 minus y divided by 2, right? Now over here we said that basically y divided by 2 is the same thing as, so here y is equal to the cos inverse of x, and therefore y divided by 2 is equal to 1/2 times cos inverse of x. 1/2 times cos inverse of x. So you can write this as pi divided by 4 minus 1/2 times cos inverse of 1/2 cos inverse of x. Cos inverse of x. So now what we wanted to show is that basically that's basically what we wanted to show, and therefore this is equal to your RHS, and therefore the identity is proved. And therefore the identity is proved. Now, question number 12 is you want to prove that basically 9 pi by 8. Question number 12, you want to prove that 9 pi by 8 minus 9 by 4 times the sine inverse of 1/3 is equal to 9/4 times sine inverse of 2 times square root of 2 divided by 3. So you have, take a look at the question here. So you have 9 pi by 8 minus 9/4 sine inverse of 1/3 is equal to 9/4 sine inverse of 2 square root of 2 by 3. Okay, so I guess we could use the formulas that we have in some way, in order, basically what we had was that not this one, but so here we had basically the sine inverse of 2x over 1 plus x squared. So I could, for example, use the sine inverse of A by B. I could use the sine inverse of A by B and write this as the tan inverse of, for example, A over the square root of B squared minus A squared. B squared minus A squared. And then what I can do is that then this would be basically the tan inverse of something. And then I could write this as 9 pi by 8 I could write it as the tan inverse of some ratio. So then I would have the tan inverse of x minus the tan inverse of y, which is equal to, for example, something like the tan inverse of, which is equal to the same thing as the tan inverse of, basically the tan inverse of something, x minus y over 1 plus x times y. And then I can write the tan inverse of that as basically as the sine inverse of something using the formula, the tan inverse of, for example, A by B is equal to the sine inverse of, for example, A over the square root of A squared plus B squared. I can do that. I'm not sure which one they have done. But it seems that they have actually used a better solution. In so let's see what the solution here is. So what they have done is that the LHS, for example, which is equal to 9 pi by 8 minus 9/4 sine inverse of basically 1/3 is equal to, you can take the 9/4 out, so you can write 9/4 times basically pi divided by 4 minus the sine inverse of 1/3, right? The sine inverse of 1 divided by 1/3. Now the sine inverse of 1/3, basically this is equal to, you can write this, it seems that you can write 2 into that's supposed to be equal to actually pi divided by 2, because you have a 9 pi divided by 8, so this is pi divided by 2. It seems that you can write pi divided by 2 minus sine inverse of 1/3. You can write it as the cos inverse of 1/3. Now let's see how. And that is based on this formula, which is basically the sine inverse of x plus the cos inverse of x is equal to pi divided by 2, right? So we said that the sine inverse of x plus the cos inverse of x is equal to pi divided by 2, and also the tan inverse of x, plus the cot inverse of x is equal to pi divided by 2, and also the cosecant inverse of x plus the secant inverse of x is equal to pi divided by 2. We had these three formulas, right? So I'm going to use this one to write this as, so based on this I can say that basically the cos inverse of x is equal to pi by 2 minus sine inverse of x, minus the sine inverse of x, which means that then the cos inverse of 1/3 is the same thing as pi by 2 minus the sine inverse of 1/3, right? So pi by 2 minus sine inverse of 1/3 is equal to the cos inverse of 1/3, and that is 9 divided by 4 multiplied by that, and then you have basically 9/4 cos inverse of 1/3. So now I need to show this. I need to show that 9/4 cos inverse of 1/3 is the same thing as sine inverse of basically 2 square root of 2 over 3. 9/4 and 9/4 are the same, which means that I need to show that the sine inverse of 2 square root of 2/3 is the same thing as the cos inverse of 1/3. Now, how can I do that? So the sine inverse and the cos inverse, so it seems that we had the cos inverse of A by B is equal to the sine inverse of, we didn't have this formula actually, but it seems that it does exist. So we have the cos inverse of, you can, I don't know how they have derived this formula, but it seems that it's actually there. So the cos inverse of A by B is the same thing as the sine inverse of basically the square root of b squared minus a squared over b, right? So you can use this formula. I will write it down. I will add it to the formulas. So I'm going to say that then therefore this is going to be equal to the 9/4, and the cos inverse of 1/3 would be equal to the sine inverse of basically the square root of b squared minus a squared, 9 minus 1, which is equal to the square root of 8 over basically b, which is equal to 3, right? Which is equal to 3. Now, this is basically, of course, square root of 8 is the same thing as you know, the square root of 8 is equal to the square root of 2 times 4, and so that is 2 square root of 2. So you can write this as 1/4 the sine inverse of basically 2 square root of 2/3, and so that is equal to your RHS, and therefore the identity has been proved. So I'm going to add this to the formulas that we had before. So I'm going to write this down here. Okay, so I guess it's enough for this video. In the next video, we will continue with these exercises. I'll see you in the next video, and thank you.